Algebra, we are continuing on with factoring, and we are on the Unit 10 Day 9 notes. Again, you can find the notes in Canvas if you need to print off a new copy. You should have had these packets well before spring break, or you can just do them on your own paper, your choice. Today we work on factoring some more. Remember, this is the same as box problems. We've been doing a lot of the multiplies to be this, adds to be that type of stuff. Today, however, there is a number in front of our x squared, which means we need to pull out something called a GCF, or greatest common factor. Greatest common factor. So, let's skip this part here. All right, and we're going to go down to here. Let's practice a GCF. So what's going to happen is you're going to look at all of the terms. So if you look at all three of these, you're going to first look to see if they all have a letter in common. If you notice the first two have an X, the last one does not. Since they don't all have a letter in common, we don't have to worry about the letter. Let's focus on the numbers. We've got 5, 15, and 10. So we got to figure out what number can all three of those be divided by. All right, so like what can 10 be divided by, 15 be divided by, and also 5 be divided by? All three of those numbers can be divided by 5. 10 can be divided by 5, 15 can be divided by 5, and 5 can be divided by 5. So our greatest common factor is 5, and we want to find the largest number, by the way, that all three of those can be divided by. Let's look at the number 2. Again, we're going to look and see if they all have a letter in common. The last term doesn't have an X, so we don't have to worry about variables. Let's look at numbers. We've got 2, 28, and 98. And again, we're trying to find the biggest number that 98, 28, and 2 can all be divided by. All right. Usually, it's going to end up being this very number here. All right, because the biggest it could be is 2. Because 2 can't be divided by something bigger than it. You can't do 2 divided by 10. So it's going to usually be that number. 98 can be divided by 2, 28 can be divided by 2, 2 can be divided by 2. So our GCF is going to be 2. Number 3 is a little bit tricky. If you notice, they don't all have an X in common, so we don't have an X as part of our GCF. If we look at the numbers, technically there's a 1 here, a 5 here, and a 6 here. All right, so we're looking at 1, 5, and 6. What's the biggest number that all three of those can be divided by? Again, the biggest the number can be is this number right here. We've got a 1. 1 can't be divided by anything other than 1. 5 can be divided by 1. 6 can be divided by 1. It's not very big, but our GCF is 1. All right, all three of those can be divided by 1, and that's about it. With number 4, okay, this time if you look at the variables, all three of them have an X. If they all have the same letter in common, that's going to be part of your GCF. And when you are looking at the variables, you're going to take the variable with the smallest exponent. The variable with the smallest exponent is not x to the third or x to the second, just x. So x is going to be our GCF. If we look at numbers, we have a 1, 11, and 10. Again, the biggest it's going to be is this guy, and it's just going to be 1, because the only number that all three of those can be divided by is 1. If you want to put a 1 here and put 1x, you can. Otherwise, just x is fine for your GCF. All right, let's look at number 5. Number 5, let's look at the numbers. We'll look at the letters next. 5, 15, and 20. All right, again, what number can 5, 15, and 20 all be divided by? Well, the biggest it's going to be is this guy. And notice all three of those can be divided by 5. 20 can be divided by 5, 15 can be divided by 5, and so can 5. So 5 is going to be our greatest common factor. Letter-wise, we're also going to have a letter. All three of these have x's. You take the x that has the smallest exponent, so that would be x to the first, or just x. This next one, our GCF, we'll look at the numbers. We've got 2 and 50. All right, and usually it's going to be this number. They can both be divided by 2. All right, 50 can be divided by 2. 2 can be divided by 2. They both do not have an x, so we don't have an x as part of our GCF. All right. All right, so there are going to be 2 steps for GCF box problems. So instead of just going straight to box problems, we're now going to have an additional step where we have to divide out the GCF first, and then we get to factor it. So here's how that's going to work. First off, we're going to find the GCF of this. So let's look at the numbers. We've got 4, 32, and 48. What number can all 3 of those be divided by? Well, all 3 of those can be divided by 4. 48 can be divided by 4, 32 can be divided by 4, and 4 can be divided by 4. So 4 is going to be our GCF. Once you find your GCF, you're going to put that right out in front. They do not all have an x in common, so x will not be part of our GCF. Once you have that, you're going to have parentheses. All right, our first term is going to be an x squared, because if you were to distribute this, you'd have 4 times x squared, 4x squared. Then we're going to divide by 4 here. So we're basically dividing everything by 4. 32x divided by 4 is 8x. 48 divided by 4 is 12. All right, if you were to redistribute the 4, we're not going to do that, but if you redistributed it, you would end up with this original problem back again. Now we have x squared plus 8x plus 12. That we know what to do with. We do our box problem. It's got to multiply to be 12, add to be 8. So those numbers are going to be 6 and 2. So inside our parentheses, we're going to have x plus 6 and x plus 2. And the GCF is going to stay out in front, so the 4 stays there. All right, let's practice this a little bit more on the next page. Okay, so for all of these problems, it says factor it out using a GCF box problem. Remember to pull out the GCF first. So the first thing you're going to do is a GCF, and then the second thing you're going to do is a box problem, where it has to multiply to be this and add to be that. So for number 1, they don't all have an x in common, so x will not be part of our GCF. Let's look at the numbers. We've got 5, 15, and 10. These numbers are all divisible by 5. We can divide all 3 numbers by 5, so 5 is our GCF. Once we have that, we're going to divide every single term by 5. So we're going to divide this by 5, this by 5, and this by 5. 5x squared divided by 5 is just x squared. 15x divided by 5 is 3x. 10 divided by 5 is 2. And now, looking at the inside of the parentheses, we can do our box problem. It's got to multiply to be 2 and add to be 3. Those 2 numbers are 2 and 1. So you put an x at the beginning of both parentheses. Positive 2 means plus 2, positive 1 means plus 1, and the GCF is going to stay out in front. Okay. Let's look at number 5. I'm going to skip around a little bit. For number 5, same idea. We want to look for a GCF. All right, this time they don't all have an x in common, and actually 1, 5, and 6, the only number that all 3 of those can be divided by is 1. If your GCF is 1, then you don't really need to do the first step. You don't have to put a 1 out in front. It's not really necessary because you're just going to end up with the same problem. If you wanted to, you could put a 1, but then you're just dividing everything by 1. You're going to end up with the same problem, x squared minus 5x plus 6. So the 1 out in front isn't really necessary because it's not changing things. And then we're just going to do a box problem. That's it. It's got to multiply to be 6 and add to be 5. Oh, I'm sorry, add to be negative 5. So those 2 numbers are going to be negative 3 and negative 2. So x minus 3 and x minus 2. So this one's not really any different than what we've been doing. Let's look at number 6. All right, if you look at both terms, they do not both have an x. But let's look at 3 and 75. GCF, they can both be divided by 3. So 3 is my GCF. I'm going to divide each of those terms by 3. So when I do that, I get x squared. 75 divided by 3 is 25. And now x squared minus 25, remember what we did before? You can put a 0x in there. And now we can do our box problem. It's got to multiply to be negative 25 and add to be 0. So it's going to be negative 5 and 5. So x minus 5 and x plus 5 with the 3 out in front. Don't forget the GCF out in front when you're done. Okay. Let's see. Let's look at number 8. Okay, if you look at number 8, we've got a 1, a 9, and a 36. The only number that all three of those can be divided by is 1. 1 can be divided by 1. So GCF isn't really going to be a number other than 1. Let's look at our x's. All three terms have an x. So x will be part of our GCF. You take the one with the smallest exponent, which would be x to the first. If you want to put a 1 in front of the x, you can, but it's not really needed. What we're doing now is we're dividing by our GCF. So we're going to divide everything by x. X cubed divided by x is x squared. 9x squared divided by x is 9x. 36x divided by x is 36. And now we can do our box problem. It's got to multiply to be negative 36 and add to be 9. Those two numbers are going to be 12 and negative 3. So we take and put two sets of parentheses, x at the beginning of both. Positive 12 is a plus 12, negative 3 is a minus 3, and our GCF is still out in front. So it looks like that. Okay. Let's see. Let's look at number 9. This guy with the 9, 126, and 216, all three of those numbers can be divided by 9. You can use your calculator if you're not sure, but these all can be divided by 9. So 9 is part of our GCF. They also all have an x. You take the x with the smallest exponent, which would be x to the first. And then what we're going to do is we're going to divide each of these by 9x to figure out what goes inside the parentheses. 9x cubed divided by 9x is x squared. 126x squared divided by 9x is going to end up being 14x. And then 216x divided by 9x, the x is canceled. 216 divided by 9 is 24. All right, and then what we're going to do is a box problem. It's got to multiply to be 24 and add to be 14. Those two numbers are going to be 12 and 2. So you write your two sets of parentheses, positive 12, x plus 12, positive 2, x plus 2, and the 9x, which was our GCF, goes out in front. I would like you to try number 4 and number 7. So go ahead and pause the video, give them a try, and then resume the video to see how you did. Okay, so for number 4, the GCF is going to be 4. They can all be divided by 4. So I divided each piece by 4, and I got x squared, I got a minus 2x, and I got a minus 8. From there, I need to do the box problem. It's got to multiply by negative 8, add to be negative 2. You get x minus 4, x plus 2, with the GCF of 4 out in front. 7, there is no number other than 1 for your GCF, so if you put a 1 here, that's totally fine. But otherwise, the x's, they all have x in common. You take the smallest one, which would be x to the first. That's our GCF. Divide each term by x. X cubed divided by x is x squared. This equals 7x, and 12x over x is 12. Then you can do your box problem. It's got to multiply by 12, add to be 7. Those two numbers are 4 and 3, so x plus 4 times x plus 3, with the GCF right out in front. Let's look at these ones. Now these ones, you'll notice it says, now we will factor and solve. Solve is your key word that you're going to be setting things equal to 0. ZPP, zero product properties, coming into play. So if you look at number 10, 4, 28, and 176, they can all be divided by 4. So if you divide each term by 4, you're going to get x squared plus 7x, and then this divides to be 44. From here, and it's equal to 0. From here, you're going to do the box problem. It's got to multiply to be negative 44 and add to be 7. Those two numbers are going to end up being 11 and negative 4. So you make your two sets of parentheses. It'll be x plus 11 and x minus 4. And the 4 is out in front. Now we get to solve. We're going to set things equal to 0. You cannot set 4 equal to 0, so there's nothing I can do with that. But I can set x plus 11 equal to 0 and x minus 4 equal to 0. All right, you're going to minus 11, giving you x equals negative 11. And add 4, giving you x equals 4. All right, we'll continue in the next video.